Saxon Advanced Mathematics, lesson 113. Our topic today is synthetic division. It's a cool name for something that you actually already know a lot about. So this is not too mind-bending of an episode, and it's not too long. There are 4 examples. Let's dive in. You know how to do polynomial division, right? It looks like this. Let's just come up with a problem that would look familiar. Let's say we have x cubed minus 4x squared. When you first look at this, you might go 0x. What that's about? Oh yeah, remember how sometimes there will be a skip in the progression of the exponents, right? We have a third power, we have a second power, but we don't have a first power, right? Pretend. So we create one by using a 0 as the coefficient, and then we have a plain number. We always want to have that smooth progression. And then remember the way that we have practiced polynomial division in the past is we say, we don't pay attention to the minus 3, we pay attention to the x. And we say, what do we have to multiply by x to get x to the third? Well, that's x squared. We multiply, we get x cubed, and then we get minus 3x squared. When we multiply them both out, we subtract. That always cancels this, and it changes this, doesn't it? And I circle it to show that I've changed it. And what I have in this space now is a negative 1 x squared, right? And I'm going to bring down this. It always looks like ox in my brain. And then I think of Paul Bunyan and Babe the Blue Ox, and I'm off to the races. But anyway, I'm going to put my imagination on hold, and I'm going to stay focused. What do we have to multiply times x to get minus x squared? Well, that will be, we need the minus sign, and then we need one more x, don't we? Okay, then I multiply, and I get minus x squared plus 3x. Right? I'm subtracting this. That's going to turn this into a plus, which I like, and it's going to turn this into, oh no, it becomes, sorry, my brain has gone sideways all of a sudden, minus x, and then I want this to be, it's a positive 3x, but then when I go to subtract it, this becomes minus again, right? This minus thing turns that into a positive. That was a positive because minus times minus, so that becomes a minus again. I get minus 3x, and now I'll bring down the 13. Okay, now, I'm ready for my last multiplication. And I ask, what do I multiply by x to get minus 3x? Well, that would be minus 3. There's my minus 3x. This becomes positive 9, but I'm subtracting all of this. That makes this positive and cancels it. Good, I like it. This minus sign turns that into a minus, so I draw that stronger, and this becomes 4. What do I multiply by x to get 4? Nah, that's not going to work. So this now I know is my remainder. And we learned about remainders in like 4th grade when we first started doing long division. But then we figured out, oh, you can actually take the remainder and make it part of the answer by putting it over this number. Right? So that is how we would do this problem using the old style of what we call polynomial division. We're now going to do the very same problem using oh my gosh, synthetic division. And what we'll see is that it's kind of an abbreviated version of this very same thing. In fact, I'm going to leave this on a separate piece so that I can compare them later. Here's the way we set it up. I'm going to copy our original problem up here. And then we had x cubed minus 4x squared. And then we had a little gap that we filled in with a 0x plus 13, right? And what I'm showing you is that I copied this same problem into this space. But what we're going to do is we're going to transform this now. Example 113.1. What I'm going to do is I'm going to take this outside expression and I'm going to consider that x minus a, and I'm going to put a in a little box right here. Now this is a -3, so notice that my a, the number I put inside this little box, is the opposite sign of that. Whoa, trippy, right? Now what I'm going to do is instead of writing all of this, I'm just going to copy the coefficients and the signs down. So that's 1, minus 4, 0, and 13. So far, so good. Then I'm going to draw a line, leaving myself some workspace in here, but I'm going to be doing some calculating, and then my new answers will be down here. Here are the steps. We bring down the first number. This is the first number. We just bring it down. Okay, so far so good, right? That's not so bad. We multiply a, this number here, and I'll put a little puffy cloud around it so you know I don't mean the word a. We multiply a by that first number, and then we're going to add it to the second number. It might be negative. We can add negative numbers, so don't let that trip you up. But we're going to add it to the second number. And then we're going to repeat that process. So let me show you what that looks like. 3 times 1, and I'm going to write this. 3 times 1 is 3. And then we add these two together, and we get -1. Minus 4 plus 3 is -1. Okay, so we're multiplying a by the first number, and then we're adding that to the second number and getting this. Now we do the same thing. We take 3 times -1, and that equals -3. 0 plus -3 is -3. 3 times -3 equals -9. 3 minus 9 is 4. Okay, now we're ready to rewrite this back. We've completed the division. We're ready to rewrite it back into a nice form, right? A nice, pretty expression. Oh, excuse me. And what we get is, now this is where we have to just keep our, oh wait, I forgot this way back there, didn't I? Okay. What we have to do is remember that, and let me show you in our first problem. As we are completing our division, each term in our answer is 1 power less than each of the terms in our original problem, right? So instead of this 1 being an x cubed, this is now our x squared term. So it would be x squared. This is our x term, so it's minus x. This is our plain number term, -3. And this last number is our remainder, as you know. So we have to write that appropriately. It's +4 over x minus 3. That's the answer to this problem using synthetic division. And let's compare it to our answer using our old school division. It was up here. I didn't even box it. X squared minus x minus 3 plus 4 over x minus 3. Synthetic division looks a little more random. I think that for most of us, if we look at this, especially because we learned it first, you look at this and go, okay, I can sort of follow what is happening here. Synthetic division looks a little more abstract, right? Because we're just plucking these coefficients off and we're doing operations with them without really seeing what they represent. Synthetic division looks weird. And that's why I'm really glad John does not teach it earlier. I know some math curriculums teach this to like Algebra 1 or Algebra 2 students. I don't like that. And I forgot to do this. Our last step is to rewrite in full terms. Okay, that's this process. These are the coefficients, and then we have to rewrite it like that. Okay, let's do another one. There are a total of 4 examples in this lesson. Okay. Numero dos. Here we go. John says to divide, and let me just show you this. He's playing this little trick on us again where he's giving us a number, x to the 4th, x to the 2nd, plain x, and a number. Where's the x to the 3rd? Oh, we have to add it in, okay? So he may scramble the order of these, or he may skip some, so we have to be on our toes as we rewrite this onto our papers to make sure we're filling in those blanks and getting the exponents all in order. This time, we have x plus 3 divided by 2x to the 4th plus 0x to the 3rd plus, now I'm ready for a squared term. He's got one. Then a plain number term. No, x without anything, and then a minus 1. Okay, so if my highest power is the 4th, I should have 5 terms. 1, 2, 3, 4, 5. That's a great way to check it, is look at your highest power, and then you should have that many plus 1, because you're going to have the descending order and then a plain number term. That's how you know. Okay, what I like to have students do when they're first learning synthetic division is always write it this way first, then translate it into that synthetic style. So the number a, remember that this expression is actually x minus a. So when we choose our a value, the sign is the opposite. So we'll have minus 3 in our little box. It's interesting because in the polynomial division, we put all our attention on the x, and in the synthetic division, we put all of our attention on the a value, the number tagging along behind. All right, now let's convert these into just their coefficients. 2, 0, 1, 2, minus 1. Okay, again, we have 5. That looks good. We draw a line and create the workspace. We bring the first number down. That one's easy, right? Now we multiply and then add. So this is going to be minus 3 times 2, which is minus 6. And so this number, 0 plus minus 6, is minus 6. Minus 3 times minus 6 is positive 18. 1 plus 18 is 19. Minus 3 times 19. Oh boy, this is getting crazy, isn't it? This is how my brain does it. 3 times 10 is 30. 3 times 9 is 27. That is 57. So this number, and let's see, it's going to be a minus 57. So this will become a minus 55, right? Because I'm adding it to the positive 2. And then negative 3 times negative 55 is going to be positive. Again, I think 15 plus 150 is 165 positive, right? Because negative times negative gives me a positive here. And then I subtract 1, so that's plus 164. Okay, now I'm ready to rewrite this, to transform it back into a proper expression. And I remember that we're not going to have an x to the 4th term, but it's going to, this kind of helps me if I mentally look across my page this way. And this is why I like to write these up here. Once you really get cooking with these, you don't have to do that, but I think it's really helpful to keeping everything on track. That'll be my plain number, and then this will be my remainder. The remainder is going to be important to us in the next two examples, so that's why I'm making a big deal of calling this out as the remainder as I write it around the circle. So here we go. Our final answer is 2x cubed minus 6x squared plus 19x minus 55. Uh-oh, I ran out of space. So this would all be in a row. Plus 164 over x plus 3. And let me double check that. 2x cubed minus 6x squared plus 19x minus 55 plus that as the remainder. This is the correct answer. Okay, beautiful. Now we have, and again, this should just all be in one row. My bad. Okay, before we do the last two examples, I want to give you a little bit of terminology. Let's look at a polynomial expression. Now, you know what an expression is. It means no equal sign. So here's what I'm talking about. X squared plus 5x plus 6. That's an expression. It's not an equation. We can't really solve it, but we can factor it, can't we? And we know that this, let's say x plus 2, x plus 3. We could write those in either order, but we know by visual inspection that 2 times 3 is 6 and 2 plus 3 is 5. So that's the proper factor. Remember, we can always factor by inspection. Remember back in the days when that's the only way we knew how? Oh, life was so simple then. We were such children. And we can't solve this, but what we can say is that if x is equal to minus 2 or if x is equal to minus 3, the polynomial will simplify to 0. And the fancy name that we have for these is that they are called the zeros of this expression. Okay, this is a fancy word that means if you put those in and then simplify, the whole thing will go to 0. They zero out the expression. Now, that is different than a polynomial equation. Okay, so I'm contrasting the word expression versus equation. We're going to take the very same expression, x squared plus 5x plus 6, except we're going to turn it into an equation. Okay, the math doesn't change, but the ideas shift a bit. We can still factor it. X plus 2, x plus 3. But this time we can actually solve it, right? Because we know using the zero product theorem that either x plus 2 will equal 0 or x plus 3 will equal 0. And then we can solve each of those and say x equals negative 2 or negative 3. And we call these the roots. Okay? That means they are the answers. These are the values that will allow us to solve this equation. So it's a fine point, this difference between roots and zeros, equations and expressions. The factoring process works quite the same, but the theoretical concept underneath is different. A root is something that you solve for, and in order to solve, you have to have an equation. A zero is something that will simplify an expression, right? These values will simplify the expression to 0. They will set it to 0, but that is not the same thing as saying we're solving it. I know, that is kind of a fussy, picky little difference. But it is theoretically useful, and I'm going to keep this page handy. And let's look at our last two examples. 113.3. Use synthetic division to see if minus 2 is a 0 of, and it gives us a big long thing. So I'm going to set this up. There's our minus 2. See if it's a 0 of x to the 4th minus 2x to the 3rd. Now we're looking for a squared term, and there isn't one. So I'm going to squeeze in a 0x. And then I'm going to do a plus 5. Notice that I've still got my x's on there. It's not in proper synthetic division form, but that's okay. I'm just getting organized. Okay, this should have a squared on it, right? 5x is plain, and then minus 10. Again, my highest variable is 4, so I perform a check. I should have 5 terms. 1, 2, 3, 4, 5. Okay, good. Now I can rewrite this with just the coefficients. 1, minus 2, 0, 5, and minus 10, okay? We're checking to see if minus 2 is a 0. I'm going to write it up here. If a number is a 0, in the way that we're using the term, there will be no remainder. Okay. So if we want to test to see if a number is a true 0 of an expression, notice there's no equal signs in this, then all we have to do is divide it and look and see if it comes out even. So let's do it. Here are our numbers. We draw our workspace. We bring the first number down. We multiply. I was showing you the multiplication here. I'm not going to do that anymore. Let's see if you can follow it. Minus 2 times 1 is minus 2. We add them. There's none of that weird subtracting anymore, like in polynomial division. That's kind of a gift. We simply add minus 4. We multiply. That gives us positive 8. That gives us positive 8, 0 plus 8. We multiply. We add. That gives us negative 11. We multiply. And we add positive 12. Now, the question is, use synthetic division to see if this is a 0. We have a remainder, and so we know that minus 2 is not a 0 of this because we have a remainder. If it was a 0, it would come out clean. Sad. Okay, and then there's one more that works exactly the same way. So we don't have to rewrite this back in the expression. All we're looking for is whether or not there's a remainder. Use synthetic division to see if minus 3 is a root of the polynomial equation, and I'll write it exactly the way John does. 2x to the 4th minus 32x equals 0. So this time John is saying, oh, this is an equation, so actually you're looking to see if it's a root. Again, terminology, it matters, but it's a very subtle difference. I put the gap in here because I saw we went from 4th down to an x. So we're going to fill this in. This is going to be plus 0x cubed plus 0x squared minus 3x, and then it's going to be plus 0 at the end, right? I'd squeeze that in right here. So now let's rewrite these 1, 2, 3, 4, 5. I don't have to write this in my synthetic division. All this does is tells me that my answer will be about roots, not zeros. Okay? It's just a terminology indicator. Okay, so let's write the numbers. It's 2, 0, 0, minus 32, and 0. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Workspace, bring down the first number. Start multiplying. Minus 3 times 2 is minus 6. Add minus 6. Multiply. positive 18, positive 18. Minus 3 times 18. Let's see. 3 times 10 is 30. 3 times 8 is 24. So that's going to be negative 24. Wrong. 24 and 30, it's 54. I was going to say that number is way too small, right? 3 times 8 is 24 plus the 30. There's the 54. Okay, good. This adds to minus 86. Oh boy, here we go. We have to multiply 3 times 86. That is going to be, I'm going to do it in just little jotty notes. 3 times 80 is 240. 3 times 6 is 18. So that is 258 positive. And it really doesn't even matter if I make a little mistake in my math here. Shh, don't tell John. Because we can see this number is nowhere close to 0, right? This would be my remainder. This would be my new x cubed, x squared, x, plain number, and remainder. But we don't have to write anything out. All we were asked is, do you think that minus 3 is a root of this equation? And when we can read minus 3 is not a root. Because if it was, that remainder would have come out to 0. Okay? These are the right answers, P.S. Okay? So we can use synthetic division to quickly test. We could use the long polynomial style too, right? But synthetic division allows us a quicker process for testing. We have to go through the whole rigmarole just to get down to see whether or not there is a remainder. We don't have to do anything else with that answer. We're just looking to see if the remainder is 0 or not. Guess what? That is the end of lesson 113, synthetic division. We'll be coming back to it, so keep it in your brain. Thank you. Goodbye.